Describe the metallic bonding as the electrostatic attraction between metal ions in a lattice and a sea of electrons. Let's start. Metals and alloys contain metallic bonding. Following are some basic characteristics, properties of metals. All metals exist in solid state except mercury. Mercury exists as a liquid at room temperature and pressure. Mercury definitely have melting point lower than room temperature. Melting point lower than room temperature. Metals are good conductors of heat and electricity. Metals have strong structure, which means they are hard. Metals have high density. Metals have high melting points. Metals are malleable and ductile. Now, if you look at this periodic table, here you'll find metals. Let's draw staircase line first. This is a staircase line. Here you'll find metals. All are metals. And above this staircase line, you will find non-metals. Look at the staircase line. This is the staircase line. And below the staircase line, we have metals only, which means they all are metals. And above the staircase line, we have non-metals. All the metals contain metallic bonding. These are the metals, the group 1 metals, group 2 metals, group 3 metals. Even you are having group 5, 6, 7. You are having metals below these. Whatever the elements present below the staircase line are metals. Or metallic bonding can be defined as electrostatic attraction between positive ions in a lattice and a sea of electrons. A metallic bonding can also be defined as strong force of attraction, strong force of attraction between positively charged metal ions and negatively charged sea of delocalized electrons. Sea of delocalized electrons. And we can represent this metallic bonding through labeled diagram in this way. These are the metal cations. This is the first layer, the second layer, this is the third layer. These are metal ions. And you have delocalized electrons. These charged Particles are mobile or delocalized electrons. Mobile or delocalized electrons. You see the metal cations and the mobile or delocalized electrons in this structure. This is the metal cation and we have mobilized or delocalized electrons. These are the mobilized.
Welcome to Chain of Qualified Tutors. Unlock your academic potential with expert tutoring, from secondary school to graduation level. Master math, science, English, and more with personalized one-on-one guidance. Call or WhatsApp for a free demo session. We offer on-site and online tuition.
The particles are metal cations. These are the metal cations. These metal cations form giant metallic lattice. Lattice is a regular, repeated three-dimensional arrangement of atoms, ions, or molecules in a metal or other crystalline solid. Let me write here. Lattice is a regular, repeated three-dimensional arrangement of atoms, ions or molecules, ions or molecules in a metal or other crystalline solid. But how these metals form giant metallic lattice? Metals have tendency to lose their electrons, valence one, to form positive ions. As atoms of metals are closely packed together, the outermost valence electrons become delocalized. You see, delocalized, these are the delocalized electrons. And these free valence electrons act like glue, bonding the metal ions together in the layers. Number of mobile or delocalized electrons depend on the group number. For instance, group 1 have one valence electrons, one valence electron. Group 2 has two valence electrons, and so on. In this video, I will talk why metals exist in solid state and hard with high melting points. All metals exist in solid state except mercury, which means metals have high melting point. It is high due to strong metallic bonding. Let me write strong metallic bonding throughout the lattice. Throughout the lattice. Hard to break bonds. Hard to break bonds. Or you can write need a lot of energy. Need a lot of energy to break bonds. Metals have strong structure, which means they are hard. Metals have high density. Again, this is due to strong metallic bonding throughout the lattice. strong metallic bonding through out the lattice. Also, metal atoms are closely packed together. Closely packed together. Again, we'll write that hard to break bonds. Hard to break bonds or need a lot of energy to break. First, relate the malleability of metals to their structure and the electrical conductivity of metals to the mobility of the electrons in the structure. Metals are malleable and ductile. First of all, you should know the meaning of the terms malleable and ductile. Malleable means can be made or hammered into different shapes. Malleable means can be made or hammered into different shapes. Different shapes. Ductile means can be made into wires. Ductile means can be made into wires. The snap below show different shapes of metal and metal wires. We have different metal products here. We have screwdriver. This is a screwdriver, keys, handle lock, etc. And on the left hand side, these are on the left hand side, and on the right hand side, the wires coming out of cable. These are due to the malleability. It's due to the malleability of metal, and this is due to the ductility of metals. Now, question comes in our mind that if metals have strong structures, then why are they malleable and ductile? Metals have strong structure. Metals have strong structure, but they are not hard. But they are not hard or rigid. Which means when force is applied, atoms can slip or slide over one another. I will illustrate it through diagram. These are the metal atoms, the structure of metal atoms having many metal atoms in it. Now we are applying force from the top. This is the force we are applying. What will happen? These metal atoms will slip. These metal atoms will slip over one another. And as a result, the shape changes. Shape. That is, they are malleable and ductile. Metals are good conductors of heat and electricity in solid and in an aqueous solution. Let's talk about conduction of electricity first. The reason behind is that electrons can move. Electrons can move or metals has delocalized electrons. What has sea of electrons? Metals have sea of electrons. Again, it can be illustrated through diagrams. These are metal atoms. We have many metal atoms. Lots of metal atoms, and they are having free moving electrons. These are free moving electrons. So electricity will be conducted through these free moving electrons. Electricity will be conducted. We know that electricity, what is the flow of current? It's simply the flow of electrons. Current is the flow of electrons. Now let's talk about the conduction of heat. Heat energy is transferred through vibration of ions. Let's talk about heat. Heat energy is transferred through vibration of ions. Through vibration of ions. Valence electrons also help. Valence electrons also help in the conduction of heat. Conduction of heat. Now this can also be illustrated through diagrams. You see the heat source here, fire or heat source. This is the heat source. Source of heat or fire. Metal atoms or ions near to it get the energy or heat and vibrate. These are the metal atoms. Now what will happen? They will get the heat. They will get the heat. They are getting the heat. They are getting a heat. That's why I'm labeling it as red. And they vibrate. In this way, it transfers the heat to other atoms. You see, heat will be transferred in this way. Mobile electrons also help in the conduction of heat. Now, where are the mobile electrons? We have the mobile electrons here, lots of mobile electrons, lots of. They help in the conduction of heat. This way heat is transferred.